Now what we're going to look at are linear equations that involve some fractions. Let's begin. In this first equation, we want to solve for x. We have 5x over 4 minus 1 equals 3x over 4 plus 1/2. And I know since most students don't like fractions, the first thing we want to do is get rid of them. So here's what we're going to do. We're going to look at all the denominators that are presented in our equation. And we're going to calculate the least common denominator. The least common denominator amongst these three denominators is pretty easy to calculate. Do you see that it happens to be 4, since we have 4, 4, and 2. Now what we're going to do before we begin to do anything to our equation is we're going to rewrite the original equation just so that at the end we can check to make sure that we did our calculations correctly by substituting our solution into that original equation. So here we go. All I did here was rewrote the equation just as it is. Again, we just discovered that the least common denominator for this equation is 4. What we're going to do to clear the fractions or to eliminate the fractions is we're going to multiply both sides of our equation by 4. Now what that means when we use a distributive property, it's going to mean that each one of our terms on both sides of our equation will be multiplied by 4. So I'll represent that in this fashion so it's easier to calculate. Now, in this first product, I see that the 4's divide out, and I'm left with 5x minus the second term, negative 1 times 4, or negative 4, and that's equal to, on the right-hand side of my equation, the 4's divide out, and I'm left with 3x plus, and finally down at the end, 2 divides into 2 once, 2 goes into 4 twice, 1 times 2, I get 2. Now, you should be smiling now that you see that we've eliminated all the fractions from our original equation. In fact, now you should be very comfortable in solving this type of equation. So let's finish it off. I see 5x and 3x. I want to gather my x terms, so I'm going to subtract 3x from both sides of my equation. When I do, 5x minus 3x is 2x minus 4 equals 3x minus 3x, that's my 0, and I end up with 2 there on the right-hand side. Now I need to eliminate the negative 4 because I want to isolate the term that contains my variable. So I'm going to add 4 to both sides of the equation. When I do, I end up with 2x equals 2 plus 4, 6. We're one step away. We have 2x equals 6. We see that we need to undo my multiplication by applying the division principle. Divide both sides by 2. When we do, the 2's divide out, and I'm left with x equals 6 divided by 2, which is 3. So all this work, and we get the solution x equals 3. Now this time, let's go ahead and do the check together. Let's write the solution up here that we just got, x equals 3, and let's make sure that that is a valid solution for this particular problem. So here we go. We have 5 times, we got x equals 3, so we'll substitute in 3 for the x, over the 4 there, minus the 1 equals 3, and in place of x, we'll again substitute the solution that we got, 3 all over 4 plus 1/2. The rest of it is arithmetic. 5 times 3, we get 15 fourths minus 1 equals 3 times 3, 9 fourths plus 1/2. Okay, now we basically have to find a common denominator here. Let's go ahead, and since these are pretty easy to calculate, let's just write them in. We want to get fourths on this left-hand side, so we know that 1 is the same thing as 4 fourths, so let's write that in. Similarly, on the right-hand side of this equation, I have 1/2, and I want to rewrite it as fourths. And most of us know that 1/2 is the same thing as 2/4, so I'm going to replace the 1/2 with 2/4. All right, now that we've done that, 15 minus 4, 11/4. Is that equal to 9/4 plus 2/4, 11/4? It certainly is. So what does that tell us? That tells us that our solution, x equals 3, is the correct solution for this equation that involves fractions. Now, let's try another problem. This time, instead of dealing with fractions, we're going to look at an equation that involves a few decimals. So let's look at our problem here. We have 2.8 equals 0.3, that's a decimal point, times x minus 2 plus 2 times 0.1x minus 0.3. Now, this is similar to the problems that involve fractions or the equations involving fractions. The only difference is now we have these decimals. And just like we don't like working with fractions, most people don't like working with decimals. So to avoid that, what we're going to do to get rid of all the decimals, notice we have tenths as our highest place for our decimals. What we'll do is multiply both sides of this equation by 10 to eliminate those decimal points. So what we're going to do is multiply each of these by 10. So I'll write the 10 by each term. I've got multiplying this one by 10, multiplying this one by 10, and multiplying this one here by 10 as well. So we're multiplying each of our terms by 10. Now, when we multiply 2.8 times 10, we simply get 28. Equals, on the right-hand side of this equation, I have 0.3 times 10, which gives me simply 3, and I rewrite the x minus 2 plus, now I have 2 times 10, which is 20, times 0.1x minus 0.3. So notice what I did here is I eliminated these decimals. Now you might be asking yourself, what about this one here? Well, don't worry about it. It's going to take care of itself. Plus, the other thing is if we multiply 2 times 10, we're not going to multiply 2 times 10 and 10 times 0.1. Not at this point, because that's like multiplying one number times another number twice when you only want to multiply it one time. So that's why we multiply it there. Okay, now that we eliminated those decimals on the outside, I hope you recognize that when you see these parentheses, you want to do the distributive property. So let's begin. We've got 28 equals, now we're going to distribute here and get here 3x, distribute again, minus 6. So far, not too bad. Plus, now here's where I told you those decimal points are going to take care of itself. We're going to multiply by 20 times 0.1x, which is going to give us 2x. And then we have 20 times 0.3, which is going to give me minus 6. So again, what did we do here? We saw the decimals out front. We don't feel comfortable working with decimals, so we eliminated those by multiplying each of our terms by 10. Once we did that, we got to this point where we applied the distributive property, and notice the resulting equation here is something that I think you're pretty confident in solving. So let's finish this problem. On the left-hand side, I have 28. I see that on the right-hand side, I have some like terms that I can combine. I've got 3x plus 2x. I know that's 5x. I see I have negative 6 and negative 6. We know that adds up to negative 12. Again, in solving equations, we know we want to isolate the term that contains our variable. In this case, that happens to be our 5x. We can do that in this case by getting rid of the negative 12. To get rid of that negative 12, we're going to add 12. But remember, the key to equation solving is this. Whatever we add to one side of the equation, make sure you do it to the other. So we'll add 12 on this other side as well. Now we're ready to combine what we've added to both sides. 28 plus 12 gives me 40 on the left-hand side. Over here on the right-hand side, I've got 5x. And of course, negative 12 and positive 12 give me a sum of 0. Now we're almost there. This should be like second nature, like you're probably sleeping by this point, but we've got 5x equals 40. We know that since we're multiplying 5 times x, to eliminate that 5, we're going to undo the multiplication by doing division. So we're going to divide this right-hand side by x, and hopefully you know this by now. Whatever I do to one side of the equation, I do it to the other. If I divide the right-hand side by 5, I certainly want to divide the left-hand side by 5. Doing that, I get 40 divided by 5, which gives me 8. 5 divided by 5 gives me 1. Those divide out. And I get x is equal to 8. Again, if you'd like to check to make sure that your solution is indeed correct, you're going to take the value 8, go back up to our original equation. Wherever you see an x, you're going to replace that x value with the 8, do the calculation, and you should get a true statement. Now again, one more time, what do we do here? It's a long process. The first procedure was to multiply by 10 to eliminate those decimals. The second step, we applied the distributive property here to eliminate those parentheses. Once we did that, we looked at each side of our equation and we combined like terms. Once we did that, we want to isolate the term containing the variable. And of course, finally, down here at the bottom, we want to isolate x so that we can solve the final equation.